In this example, we're going to see how to use Animation Designer to solve a sketch. This is a great free body diagram of a piston, where as you'd expect, the piston goes up, the crankshaft goes around. As with any animation, it's a three-step process. First, let me go to the Animation Designer tab, is you select what can move through the use of rigid groups. Then you select how those rigid groups can move through this application of joints. Then the third step is the application of motors to get the system to spin these joints around. So let's activate our Animation Navigator, and notice there is no solution. You can create a new solution here, or it will just add one automatically whenever you create any command in Animation Designer. I'm the lazy kind of guy. I'm just going to create a rigid group and let the magic happen for me. So I want this piston, these four lines, to have be in a rigid group. And as you would imagine, a rigid group is exactly what the name implies. It's a rigid group of elements that can move around all in one, like one body. The connecting rod, we want it to rotate around, just like the crankshaft, which is this single little line down here. And last but not least, I want the center line and the crankshaft's path to all be one rigid group. I'm going to lock that down a little later on. Alright, now that we have our rigid groups, notice how you can highlight them. You could double click one if you wanted to, you could add more, you could change the color and all that kind of good stuff. Or my personal favorite is go to the rigid group color, and you can change its color to get it to show in its rigid group color. Very easy way to identify what is in what rigid group and what is not in a rigid group. Alright, that's step number one. Step number two is to apply joints to these rigid groups. I personally like to leave the rigid group color on for the steps so I know exactly what I've got. For example, the joint, I'm going to add a fixed joint to lock everything down, like the center line, for example. We also have a revolute joint, which will spin something around, a slider, which will slide something back and forth, a cylindrical joint, which will slide and rotate, and a spherical joint, which is like a ball joint. So let's go ahead and add a fixed joint between, well, not between, but just to this sort of structure that's going to hold everything together. As I hit apply, what it will do is will enter that inputs into the system and prepare me for the next joint. I like the piston to slide up and down, so I'm going to use a slider. And the first object is the piston itself. The second object is this center line here. And the vector, you could pick the center line if you want to, or this triad direction. It doesn't matter. I'm assuming both these are in the same direction here, which I think they are. You can go ahead and pick the center line if you feel more comfortable with that. And for this example, the direction of that center line doesn't matter. You'll see later on that it will in other examples. Hit the apply, and we have a few more joints to create. I want to create a revolute joint. So the crankshaft here needs to spin about that center point. So that's the first object. The second object will be this large fixed structure. And I want to rotate about this axis here. And even though the axis is way out in left field, you have the ability to specify where the point is of that axis, and that's at the center point here. We just guessed at which end to pick here, but generally we get this in the right orientation. Also notice the direction. It doesn't matter in this case, but when we apply positional motors and things, the direction of the joint may affect the direction of your travel. So let's hit the apply, and just a couple more joints. A revolute joint between the connecting rod and the crankshaft. So we're going to pick the first connecting rod or crankshaft, then the connecting rod. It's going to go about that axis, and we didn't get the direction right that time, so I'm going to have to pick this point right at that end. And the vector should have been along this direction here. I think I may have missed that step. Now that's going to rotate about that vector at that point. And I believe we have one more to do, and that's between the piston and the actual connecting rod itself. So as you guessed, we'll pick the piston. Second object will be the connecting rod about that axis and at that point. And that should be all of the inputs that we need to specify. Hit OK. Now, if you want to see what your joints are, you can of course click them in the navigator and you can see how things are. You can also right click on the joint folder itself and hit show joints in the graphic window, and it shows all of the joints. We are going to apply a motor to one of these joints, so sometimes it's good to see all of these joints live so you know which one you're picking. If you wish, there's a move rigid group command. You can select that command and pick any rigid group here that's not fixed and click it and grab this triad and rotate things around, and you can see how your model sort of comes to life. This is a great tool to use before you start applying motors. Maybe you forgot a joint, maybe it wasn't on there right. This is a nice verification tool to tell you how things are going to react before you put a motor on. Step 1, rigid groups is done. Step 2, my joints is done. Step 3 is let's add a motor. Let's just go real simple here, and we're going to add a speed motor to one of these joints, and probably the crankshaft. And I'm going to give it a speed of 100. And what a speed motor will do, it just runs continuously like a fan or a compressor or something like that. Now that that's done, just hit the play button and this thing will rotate around for you. This is a real simple example here, but the key point is how you can use Animation Designer to solve free body diagrams like this piston example here.